Now let's talk about some things in practice. So I'm going to move slightly. This isn't really layer 2 yet, but I just want to note. Who invented the telephone? Do you guys know? See, you guys still remember something. Here's your trivia of the day. What was invented first? The telephone or the light bulb? You know that's going to be a trick question. Telephone. Telephone was first. All right, so Alexander Graham Bell. What was Alexander Graham Bell's assistant's name? Oh, come on. The first message, what did he say? Watson, I need you. All right, so Bell, his great invention was this little funky looking microphone thing connected to a box. There's an electric wire running to a very similar looking box and another Bell thing, right? And so he could talk in, and then the voice came out. What's the topology here? No. This is a point-to-point topology. By the way the phone was made, it would carry conversations both directions on the same cable. We aren't going to worry about that. All right, this is a point-to-point topology. Can you imagine what the phone system would be like if everyone was connected? Wouldn't that be fun? Like everyone in your same apartment was connected to the same, in your apartment building is connected to the same cable. Actually, they used to do that. They called it a party line. And everyone, you had to get the line free. And if all your neighbors were on, you couldn't talk. And so you'd have to pick up the phone and be like, get off the phone, I need to call the doctor. And get everyone to hang it up. So those were the days. Well, okay, we can agree this is not a very good way to make a business. If you wanted to create a global empire of phone service, what would you do in order to make it so you could have more customers? We're going to change the topology. You better believe we'll change the topology here, but how are we going to do it? Let's draw it over here. So I used to watch the Waltons when I was really little. This is how old I am. When it was on first run, by the way. The Waltons. Come on, you guys know the Waltons. There's a guy named John Boy. Yeah, right. Okay. So John Boy has a phone. Okay, he's in a town. There's Doc Smith over here. He has a phone. And now John Boy needs to talk to Doc Smith. Okay. Now we're in a star topology, and these people, I don't know what these other people are. This is just John Boy needs to get to Dr. Smith. Right? So how are we going to get to, we were on this system, right? We had one cable connecting between Bell's phone and Watson's phone. How are we going to make this do basically the same thing? How does John Boy make a phone call? Come on, you haven't seen old-timey shows? What does he do? He picks up the phone and he says, Mabel. Doesn't Andy Griffith do this too? Call the operator. So it's the operator. And the operator has a little headphone on, and she's picks up the phone hello, operator. And John Boy says, connect me with Doc Smith. I'm not going to get into it too much. Once she figures out who he needs to connect to, she plugs a cable, and one end of it goes in here, and one end of it goes in here. Okay? And what that does is it completes the circuit. So the oh wow, look at that. So the operator would be considered the human switch. So they call this a switch.
He's just turning into a point-to-point though, right?
Uh-huh.
Is that all a switch does?
We'll worry about that later. But this switchboard operator is going to complete the circuit. If someone else calls, by the way, she can do other circuits down here. She could connect those people, right? And then when their call is over, she just unplugs them. The light, there'll be a light on, and when the thing, I don't know, it blinked. I don't know what it did, but she would unplug it when it's over, okay? So the switchboard operator completes circuits, right? What am I trying to do here? So there's physically this connection between John Boy's phone and Doc's phone, okay? This is called circuit switching. New switches don't do circuit switching, they do a different switching. We'll get into that later. So circuit switching, we have a physical, basically, connection between two devices, okay? The thing we like about this is that the capacity is reserved all along the way, all right? So this is reserved, this circuit is reserved for John Boy and Doc. Okay, we'll just call him John. Between John Boy and Doc, okay? We're cool with this, right? It's reserved. Only they use it, and as long as the circuit is engaged, it's their stuff, right? So we like that. I don't need to get into that too. All right, circuit switching is great when you're having a conversation. Okay, so I've got John, and John is talking, so I'll draw in his talking. So while John is talking, he's using up this part of the line. When John is not talking, and then when Doc is talking, usually they just take turns. You guys had calls like this, right? Hello, Grandma. How are you? I'm fine, Russell. I hope you had a great day today. That's great, Grandma. Right? We're taking turns, right? We've had those awkward calls where it's, what do you want to do today? You can't do that, right? You can't have this dead silence. Circuit switching is good. Oops. It's good for voice and video. That's because the line is always in use. Okay? So the idea here is if John Boy is not talking, then usually Doc will be talking. So it made sense to connect them together to reserve this capacity. All right? We can also hopefully see, if we go back here to our star network, right? Our multiple conversations. This especially makes sense when we have video or voice calls. We can have these multiple conversations going at the same time. Are we good here? All right, data traffic. Oh, we need to take a break. Yeah. Data traffic is what we call bursty. Okay, we use this fancy term called bursty. And what happens here is I might have a web client, and I've got this connection I could be using, right? And then there's a server. And what I'm going to do is, oops, I'll draw the server in. I'm going to send a little baby request in for the file I want. And then the server is going to send back some stuff. And then I'm going to read the page I got. And then I'm going to later send another request. Oops, and that should overlap. That's okay. And then the server is going to send back another thing. Okay? So bursty means a short period of a lot of traffic followed by a gap, and then another burst, short period, followed by a gap. Okay, so we got here, what am I talking about here? That's bursty. And this is pretty typical on a LAN. So I may, for example, request my email, get my email, and then I spend a little while reading my email. So there's not going to be any traffic while I'm reading it. And then, I don't know, I'm going to stop and then go to the web and whatever else I'm going to do. Download that extraordinary spreadsheet I need to do. None of you guys are accountants. What do we download? I'll get the source code out of the repository and then work on it for a while and then upload it. So there's bursts followed by a gap. This is inefficient. It doesn't make sense to reserve that capacity if we're going to have bursty traffic patterns. Usually we want to have shared, basically multiplexed links. Okay, that's how we're going to accommodate for it. For example, here, if we think that, you know, someone is just going to request a little bit of web traffic here and then there's going to be a gap, well, we'd like other users to be making up the difference in here. We don't want to just waste all that capacity. So it doesn't make sense to just have a full circuit switched network in. That's like what we're talking about here. Okay, remember we had the core here. In here is going to be where the servers are, right? And most of the time, people out on these stars, out in the departments, are going to be getting data off of the servers, and it's going to happen in bursts. So, you know, here's this person wants a web page, burst. Then they stop. And hopefully this person now wants a web page. And that's why here we might have, let's say, 40 stations connected to this switch, but this trunk line can only support 10 conversations, or 10 times the data rate, okay? So that means out of these 40 people, we expect 30 of them to be sitting there staring at their computer and not accessing the network. We good with that? At any one time. So we kind of deal with probabilities here. This is what we call, so we use, this is what we call packet switching. And I feel like I want to break. My back is starting to hiccup on this chair. Yeah. All right, so let's go back to our note-taking here. So, packet switching. Most of the packet switching stuff we'll talk about is, you know, for example, Ethernet. We're going to be going on one cable or one wire, and all you're going to do in terms of packet switching is each frame needs to be sent differently. And this is just multiplexing like we were talking about. The difference is when it gets to the switch, oops, I'm supposed to be black here, sorry. Track all my different stuff. When I get to the switch switches things out based on the packet, not based on a circuit. So based on what's in the frame, the switch sends the green packets out that, and the orange packets out here, or the orange frames. Okay? So that's the basic thing here. I do want to note, if we go back to our little switchboard operator here, they still do circuit switching in the phone network, but all this is automatic. You guys have seen the rotary phone where you flip the dial and it goes the little that actually ran an old style mechanical switch in the old days. And it made it so you were connected to a certain location. Come on, that's awesome. The ones now, you know, you punch a touch tone, it does the same thing. So there's stuff all along the way.